Tell me any word from here that you have not touched upon. A hypothetical population, was it mentioned?
Yes.
Yes, a hypothetical population was mentioned. Random sample was mentioned.
Yes.
Some sample from a hypothetical population. Statistic was mentioned. The
Yes.
word? Very good. So statistic is some summarization of that random sample. Okay. So some function of those random observations, which itself is again a random variable. Importantly, null and alternative hypothesis were mentioned. Something tested against something, and p-value was mentioned. How to take the decision. P-value is large or small. What decision will be taken based on p-value? These are a few prerequisites that I will need and which you can help me out with when we come to these portions. So, my talk would be oriented around a data set. I will not say one data set, but I will say two data sets. So, my starting point would be a data set. Okay, so I think this is not the correct one. Let me come to this first. Please come to this one. That is, I will be talking on two data sets. First, a data set of 400 customers on certain variables. These customers, the data set would be of these 400 customers who uses credit card. Another one would be the record of 10,000 customers, again related to something with credit card. So I come to this credit card data set first. So the entire talk would be based on certain questions related to credit card data. We will try to answer a few questions based on this data set. See, there are a lot of variables over here written down. I just go through the variables, but we need to understand the nature of the variables as well. What are the variables? See, default, limit, income, balance, age, rating. There are many more. Before moving on to the next page, I once again come back to these variables again. See, default. Default means that is here whether the customer is a credit card defaulter or not. That means it is some sort of a binary. It will take either the value 1 if the customer defaults, and it will take the value 0 if the customer will not default. Limit. Limit is the amount of money available to a credit card holder. See, all of us are not given the same limit in the credit card. So there is certain thing that is maximum what limit I can get. Here it is a numeric variable. It is some sort of a real number, or it can take any real number. So limit is a numeric variable. Income. So how much limit you would be sanctioned, also it might depend upon certain other factors. Or here we go first by this thing that income. So what is the income of the credit card holder? Here it is in dollars. Okay. Balance. It is a very important variable. It denotes the credit card balance, means the amount of money you owe back to the credit card issuer. Age is the age of the credit card holder. That is the age. Rating, it is a score. So age, you can see age, balance, income. These are all numeric variables. Rating is a score. So the credit card holder also gets some rating. It depends upon how her repayment options or how she is repaying her credit card loans. So based on that, the credit card issuer also rates the credit card holder. This rating, it is also a numeric variable. Come to education. Education would mean it is the number of years of education of the credit card holder. Years of education means maybe 10 years, 12 years, 13 years, 18 years, whatever it is. Cards is the number of credit cards a person will possess. One might have more than one credit card, so cards would be that number 1, 2, 3, etc. Married. Married is the marital status. That means it is taking two values. You can say again yes or no. If the person is married or whether the person is not married. You might be thinking how all these can be connected. Yes, these will all be connected. Later, we will see. Student. Student is again a binary. That means if the credit card holder, whether the credit card holder is a student or not. So it is also a binary, yes, no. Gender, it is also binary, whether the credit card holder is female or not. And then there is an ethnicity, it is based on the US data. So it is African American, Asian, Caucasian. So there are three categories of it. See, these three categories, 1, 2 and 3 written, this 1, 2, 3, do not treat them as any numbers. Okay, these are not numbers like your years of education. Years of education, when I say 10 years, I know how many years of education the person is in. But ethnicity equal to 1, I could have even said ethnicity equal to African American equal to AA. I could have used a text value also. So here this 1, 2, 3, don't treat these 1, 2, 3 as numerical figures, treat them as categories. So the categories are labeled as 1, 2 and 3. So these are a few variables that are present in the two data sets. One data set is your credit card data set, another data set that I will be using is the default data set. Now I have a few broad research questions first. Then I will come one by one to specific research questions. Now start looking into the questions carefully. Okay? You have to interact now. First, the question is, what factors influence credit card limit and how do they affect it? That means how much limit, credit card limit a person can get. What are the factors that influence that credit card limit? And if the factors influences the credit card limit, then in what way? That is my first question. Question 2 is, given the information about Miss X on all the variables 2 to 11, what credit card limit can she be approved for? By this I mean, that is, I am supplying you with data on certain person whose all information I will supply, but I do not know what credit card limit can Miss X be approved for. So can you just give a suggestion how much credit card limit Miss X can be given if I give you all the demographic details of Miss X? That means her age, education, income, marital status. I want you to give me back a predicted value of credit card limit. Question 3 is, given the information about Mr. Y, we would like to know, naturally this question the bank usually likes to know. This is not our concern, but the banks are really concerned about when they issue a credit card and when they issue the credit card limit, how much limit you can get. They also study our profession, our income and everything, and they also make a prediction, that is whether this person is a reliable one, depending that is whether this person would default or not. They also make their own calculation. So third is a very important question from bank's perspective. They would like to know the person to whom they are giving loans will default or not. So these are the broad questions. Each of these questions would open up a new area, and that we will touch upon. So this was the backstory. This was how we will start now. Okay. So just keep in mind that is we have information on credit card related things and we have these broad questions in mind. Now I introduce the topic. See, two terms that would be very, very important over here. One is response, another one is predictor. These are the two terms. One is response, another term is predictor. Response may be also, I would write using 1. The symbol for response I would use 1. And symbol for predictor, which has got so many synonymous names, I will denote by X. If there are more than one predictor, X1, X2, X3, X4, likewise. So the question is, what is a response and what is a predictor? Within bracket I have mentioned that response is the dependent variable and predictors are the independent variable. See, I ask you one very simple question. Suppose I have that amount of rainfall. I have amount of rainfall over the different months of a year in West Bengal. And I have the growth of, say, paddy. Same thing. Then which one depends upon which one?
Rainfall.
Amount of paddy depends upon rainfall.
The growth of paddy, how much paddy will be grown, amount of paddy, that depends upon the amount of rainfall. So you have to keep in mind. So if that is the case, then your amount of rainfall is causing the growth of paddy. So that amount of rainfall is independent variable or will be the predictor. That amount of rainfall is affecting the growth of paddy. Growth of paddy becomes response. That's it. So with this concept, I want you to identify the response and predictors for questions 1 to 3. I'll again go back to 1 to 3. Okay? So this is clear. Response, predictor, which one is affecting which one. That's right. Question 1. What factors influence a credit card limit? How do they affect it? That we will answer later on. So, what factors influence a credit card limit? You just tell me which one you think to be the response.
Salary. Income.
Income.
Salary.
Response is limit.
What factors influence a credit card limit?
That may be income, age.
No, not it. Credit card limit is the right answer. The credit card limit is your response. How much limit you would be given depends upon several factors that I have discussed. I can go back. See again, keep in mind the amount of paddy depends upon the amount of rainfall. So the amount of credit card limit will depend upon several factors. So this amount of credit card limit is my response. I will call it 1. And the rest, as you was mentioned, there will be other factors. Question 2. Given the information about Miss X on this, what credit card limit can she be approved of? Again, response is the credit card limit. Question 3. Given the information on variable 1 to 11 for Mr. Y, whether he will default on his credit card or not. Which one is the response?
Default.
Default. That means whether the person would default or not. It is binary, 1 or 0. Anyway, whether it is binary or not a problem. But the response is default status. Either I default or I do not default, and whether I will default, that would depend upon several other variables. So these are the responses in questions 1 and 3. Next, quickly I come to two terms again. First I come to regression versus classification problems. You see that regression and classification, sometimes we use the word synonymously. We call everything as regression problems. But whenever, so you have identified the responses in question 1, question 2 and question 3. If the response is quantitative, numerical, then you call it a regression problem. If the response is binary, binary means yes, no. You call it a classification because you are classifying something. So out of 1, 2 and 3, which one is regression problem?
First one,
1 and 2 are regression problems because in both 1 and 2 the response is numeric. It is the credit card limit. Whereas in question 3 it is binary, so it is a classification problem. So these two terminologies are very important, whether it is a regression problem or whether it is a classification problem. Next point I come to inference versus prediction problems. Again we synonymously use these two things which should not be used. Look into the term inference and prediction. See, inference would mean I would like to study the nature of all the predictors and how they are affecting my response. So the relationship is more important to me. That is whether a high income group person is getting high credit card limit, whether a married person is getting high credit card limit. So the relationship, that is more important. If the relationship is more important, then I call it an inference problem. But suppose I'm not interested in the relationship. What I want to know, what is the answer, the predicted value. Means I do not bother about the relationship, whether it increases or decreases with this or that. But I want one answer. I want to predict something, then that would be called a prediction problem. If that is so, once again, please revisit questions 1, 2 and 3. Can you tell me out of 1, 2 and 3, which one is an inference problem and where I want to give some prediction?
One is inference problem.
One is inference problem. We are trying to study the nature, how the credit card limit is influenced by these predictors. 2, I want an answer. I have information on Miss X. Tell me how much credit card limit you can approve. That I'll ask the bank. And question 3 is also a prediction problem. Here, information on the customer is known and the bank wants to predict whether the customer would default or not. So 2, 3 are basically prediction problem. 1 is an inference problem. Usually what happens, we use the same model for doing inference as well as prediction. But now with advancement in technology, it is seen that the same model doesn't always work out well for inferring as well as for prediction. And with these machine learning techniques, further complicated models are available where you can predict very accurately, but maybe you cannot explain. And rather, they do not want to explain also sometimes. See, in question 3, maybe the explanation is not important, but the prediction is important. So, if prediction is important, use a more complicated model. That is the thing. With machine learning techniques, we can do that. So, we will make a distinction, that is inference and prediction problem. Right away, we will not focus much upon complicated models. There are several, so these were the broad questions. You can recollect the questions that we have in mind. So if these are the broad questions, how can I handle these questions? The tools. A list of tools are here. Naturally, I will not go through these tools, all these tools, but I will touch upon, see, these are becoming complicated. Regression tree, classification tree, bagging, random forest, hosting, all these are machine learning tools that are available and very suitable for prediction purpose. This linear regression, logistic regression, mainly for explanation purpose, they also do the task of prediction. So I will touch upon only a few tools. So that was the introduction part. So the questions we all have in mind, and we want to answer those questions using the credit card data. That is my setup right now. Okay. So you see that Now I have broken the questions into fine parts. First I made 3 questions. Those 3 questions I will divide. I have 10 questions to answer. Let's see how far we can proceed. Question 1. Does income affect the credit card limit? Specific question. If so, how and to what extent? Okay. So the question is, does income affect credit card limit? If so, how and to what extent? Is it okay? The question is okay? You see that I am using this art studio where there are 4 paints, and I am using only these 3 paints are over here. This is a data set inbuilt in R. The library for this is ISLR. You have to install certain libraries to get the data. And this library, you have to run this line by line. So this library is there. I will be attaching this data. Attach would help you because then if you just use this symbol attach credit, then whatever variables are there in this credit card data set, you can use those variables without again referring back. See, I use another thing so that you can also have a look into this data set. VIEW, view credit. So if you, with a capital V, if you view this data set, see here this is the data set ID. There are 400 customers. Here it is written 400 entries, that means data on 400 customers are there. 12 total columns. One column is ID, then there is income limit, rating card, age, education, all those things that we were talking about. Okay. So this is your data set, you can have a look, and there will be 400 such rows. STR credit would give you string. It would give you the nature of the variables, how the variables are, whether they are numeric, whether they are factor variables, all those things. Now, you see that the first question, if you can remember, that is whether credit card limit depends upon income. So quickly tell me again, which one is the predictor and which one is your response? Whether credit card limit depends on income. So predictor is income and credit card limit, that is your response. So whichever is the predictor, plot it on the x-axis and the response will be plotted on your y-axis. And the x-axis term that would come first. So I will write plot income limit. So if you make a plot of income and limit, you see you would get something like this. You get some plot like this. This side is income, this side is limit. Okay. So any impression from this plot? What is your idea from this plot? Higher income and the limits are over here. So
Higher income increases the positively correlated.
Positively correlated, or what you was mentioning, higher, if you are in a high income bracket, then you will get high credit card limit. That's for it. If you belong to a very high income group, higher your income, you would have the bank would give you a high credit card limit. That is for sure. So that is the relationship at a glance, graphically we can grasp. But for any further analysis, we want to have a model for it. That means I want to model these dots. How do I model these dots? We have to simplify the thing. We have to use a certain simplification of all these dots. It seems as if there is a straight line. It seems it might not be very good, but we have to try with certain functions. Okay? So it seems as if we can use a straight line. So you see that we are joining it with a straight line, or we are fitting a line. You see that a straight line is drawn over here. What does this straight line indicate? This red colored line, it shows that all these points or all these black dots, they do not fall on this straight line. Okay. Some dots are above the straight line, some dots are below the straight line, and some may be on the straight line. But to develop a model, we should have this straight line equation. An equation of a straight line, we all know it is y equal to a plus bx. Okay, so I plan to use the board as well. I don't know whether it would be possible now, but I would like to use this thing because you see, so we have come up to this, that there is a scatter plot. Through that scatter plot, we have done a straight line. Some points are above, some points are below the straight line. And the equation of the line is y equal to a plus bx. But I do not know this a and b. So by some way, I have to find out this a and b as well. Can I use the board also? But before I come to this board, you have a look over here as well. So you see that there have been some scattering. Okay, some scatterings. I am just passing a straight line. All the points, they are not falling on this straight line. But I am assuming that y is what? Y is my limit. Because we have agreed upon that limit is my response. So 1 equal to a plus b into income. This is the equation of a straight line. Y equal to a plus bx. So now I write limit I. That means the limit approved for the ith customer. That would depend upon income of the ith customer. But if I just write limit I equal to a plus b into income I, all this scatter of the points are not satisfied. Because to satisfy this, all the points must fall on the line, right? But they are not falling on the straight line, and it will not happen that they will all fall on the straight line. Because this is something real life phenomena, and this is something mathematical. We are trying to capture the real life using a mathematical function. So what we write is some error I. So this error, sometimes it is 0 when it falls on the line. Sometimes it is positive if the dot falls above the line. Sometimes it is negative if it falls below the line. So this is my model, a very simple model, limit equal to a plus b into income plus error. So what are unknown? Unknowns are a and b. So somehow, with the use of the data, you see the simple linear regression model. This is my simple linear regression model. And I have mentioned one assumption over there that I would require later on. That assumption is on the distribution of error. So I will assume you have come across normal distribution. Have you heard about that? So I will assume that error follows some normal distribution. This simple assumption, whatever is this, we have to assume normal distribution is symmetric, being shaped, no problem. So this is my model, and that is where I come to simple linear regression model and assumption on it. Why linear? Because it is a straight line. Why error? Because all points are not falling on the straight line. Least square theory, it is a very powerful tool. Least square theory is a powerful tool. What it would do? Somehow it is a mathematical technique which would help me to get an answer of A and B. It would help me to get an answer of A and B based on the data. So that is the technique. We will not go into the mathematics of the technique. From where these hat are coming? These are coming by a technique called least square theory. And this least square theory technique, when applied on the data, is giving me some answers of A hat and B hat. Now you tell your income. I put your income over here and I will tell you how much credit card limit the bank will give you. Okay, so you give me any income of you, of your friend or anything, I'll put it over here. Already the least square technique has given me answers of A and B, which are A and B hat. I'll plug it, I'll multiply, I'll add, and that would, then I can tell you, see, if your income is this, you can be approved of such limit. Maybe not exact, but there could be certain error, but roughly on the average you would be given this limit. So that is your least square estimators are this A hat, B hat. And how do I interpret it? Interpretation, forget about A hat, just concentrate on this B hat, which is very important, which would mean that if your income increases by $1, here it was in dollar, if your income increases by $1, then your approved limit will increase by B hat amount. I am not sure whether you are aware of derivatives or not, but if you are aware of differentiation, then if you differentiate D limit, D income, you would get the answer B hat. I am not going into the derivatives, I am just saying in this way, you increase your income by $1, then the limit approved, that would be increased by B hat amount. So that is the interpretation. Standard error. I don't know whether you have heard about this term standard error in last class. You have heard about it. So whenever there are certain estimators, and I am saying that they cannot capture the truth correctly. So there would always be an error in your estimation. And then the variance or the square root of the variance of these things, they are called the standard error. Just remember that whatever I am writing over here, it cannot capture the truth exactly. These are all guess values, and we would see that how accurate our guess values are. Standard errors, if standard error is high, that means your estimators are not very precise. That is the thing. If standard error is low, that means yes, your estimators are precise. Hypothesis. If you can tell me, what was my question? My question was, does income on this limit, whether limit depends upon income or not. Credit card limit depends upon income or not. That was my question. Can anyone frame the null hypothesis for me from that English sentence?
There's no relation between income and credit.
There is no correlation between income and limit. Okay. If there is no correlation between income and limit, that you want to place at H0. And H1 will oppose that. Can you just capture, she said it correctly, capture it because my symbols are limited. I don't have that correlation symbol over here. Can you capture that from this A and B?
Limit varies as.
No. She mentioned that there is no correlation between limit and income. That means limit is not equal to, I cannot write all these things. I want it just in terms of, these are my parameters now. She mentioned correlation. Unfortunately, I do not have that correlation parameter over here directly. But see, if I have put B equal to 0, what would happen then? If B equal to 0, this term will vanish. Independent of income, that's what she mentioned. So I have to catch it from over here. So B equal to 0, B is not equal to 0. So if H0 gets accepted, that decision we will take depending upon the p-value If H0 gets accepted, then my model will not have this portion, and I'll say that no. Income is not influencing limit. But if this H0 is rejected, rejected means you come over here. That means yes, income is very much in the model, so it is influencing. Okay? So that is it would depend upon the p-value, and one thing left is the test statistic. The test statistic, the software would give you a test statistic answer, and it would also give you the p-value answer. So depending upon the p-value, you will be taking your decision whether to accept this or not to accept this. So what decision we will be taking, let us see, for this question. So we haven't lost a track of the question, I think. The question was whether limit is affected by income or whether income influences limit or not. A very simple function in ours, that is the ln function. Just ln function, ln limit tilde income. If I write, limit is my response variable, I write it first. Tilde, this symbol gives you the entire model. You do not have to specify a plus b xi. You would understand that you are just doing a simple linear regression model, because that is by the symbol ln, linear model. And income is your independent variable. So if you just run this, and you have a summary over here, if you make the summary of this thing, I'll show you what has come out. Look here, forget about these, come to the coefficients. Intercept, income. Can you tell me which one is A hat from here? Which figure is A hat? Forget about this. Concentrate only on the estimate column.
23.
2389.869. So they are automatically giving you this linear regression technique. So this is your A hat. Just by use of the function ln. Income. This 51.875 is not income actually. This is the answer of B hat. B hat. So now you know A hat. You know B hat. And you can put any income, multiply it with 51.875, add 22389. You will know how much credit card limit that person can be approved of. Standard error, I mentioned that there are uncertainties involved with this estimation. These are only estimator, not the true value. These are the standard error. I told you about the test statistic. The test statistic we will denote by t-value. The software also denotes it by t-value. Its formula is very simple. What we do is that it is estimate divided by standard error. They have done this division for us. So we will not focus on this. What is more important is the last column. This last column, you see probability this greater than something. This is what you have learned in yesterday's class called p-value. So your last column is providing you with answers of p-value. How much are the answers? It is e to the power minus 16. This is 0.00000000 15 times, then 2. So is the p-value high or low? Naturally very low. Very, very low. If the p-value is very, very low, what would you say? Strongly. So you strongly reject your null hypothesis. You focus on income. Okay. So you focus on income and you strongly reject your H0. If you strongly reject your H0, then explain the decision in English language. Then what is your decision now? Income depends on, or rather limit depends on income, or income substantially affects or determines the credit card limit. In any language you can write it, whatever is the thing. So you see that just a function ln has solved our problem, but my question was also very simple. I have chosen only one predictor, that was income. See so far. Question 2, I have chosen another predictor, a new predictor. Does the credit card limit depend on whether the customer is male or female? Is there some partiality in giving more credit card limit to males than to females? I just thought about that. I don't know. So this was my second question. Second question and the first question are similar looking. Where is the difference? Where is the difference? Which one is my response still? Credit card limit. So response is still same. Predictor, earlier it was income. Income was a quantitative variable. But now it is gender, which is categorical, male or female. Okay, so I want to answer that. So I wanted to know, not income, whether there is some partiality regarding gender. Let's see what data has to tell us. So that would be my question 2. And if I follow that same technique, no problems so far. So again it is ln, the function is ln, limit is my y, and gender is my predictor x. So if I run this again, and if I make a summary of this, I get certain answers. See what these answers have to tell. Again it is A plus B gender. See here intercept, this is 4713.17, it is your A hat. Gender by bracket or by sign it is written female. That means they are showing it for the female. So if female, they will keep it in the model, female is 1. And if not female, then it is 0. That is why they have mentioned which one the software has automatically treated as 1. So gender female 43.35. No problem. Standard error, T values are all there after division. Then we will quickly look into the last column. This is my last column. What is your conclusion? P-value is low or P-value is high. Which P-value you would look into? There are two P-values given. The first P-value corresponds to a testing of the intercept. That is the testing of A, in which we are not interested. My focus is in the testing of B. That is that slope. What about the gender female? P-value is how much? 0.851. Maximum P-value could be 1. 0.851 is a very high value. So, what about your, what do you do now? Accept H0. Accepting H0 means what in language?
Independent of gender.
Independent of gender. That means there is no partiality whether female or male. Credit card limit does not depend upon the gender of the customer. Okay, it depends on the income of the customer, but the data shows that it doesn't depend upon the gender of the customer, not at all. This P-value is very high. So look into which P-value we want to focus upon. This was my second question. Okay. Next, I'll move on. I said I'll move on from simple linear regression to multiple linear regression. Naturally, since I have so much of variables, why should I use one variable? Maybe all are affecting the credit card limit, maybe not gender alone, maybe not income alone. You just have a look into this model. What I have written, now I have added all the variables. Whatever was over there, limit. This is my beta naught is like A, B, C, D. I have written beta 1, beta 2, otherwise there would be too many alphabets has to be taken. So I have taken everything. Whatever to me. And then this is my error I, or I've written in short epsilon I. This would follow normal 0 sigma square. Look into my question 3, 4 and 5 simultaneously. Let us have a look into the questions carefully. Question 3 says, is at least, you have to be careful with this question. Now, what is the change that I have made? I have incorporated all the predictors into my model because I am having a feeling maybe income alone or maybe gender alone is not enough. What about the other variables? I want to see all at a time. Is at least one of the predictor useful in predicting the credit card limit? This is question 3. Try to get the question 3 first. Question 4 says, do you think that income is an important predictor in assessing the credit card limit after eliminating the effect of all other predictors? Question 5 I can leave for some time, not right now. Question 3, question 4 for the time being. Is at least one of the predictor useful in predicting the credit card limit? This is one question. And the next question is that. First, we'll ask you about question 3. Is at least one, means my main focus would be on what would be my null hypothesis. Now, you have the model over there, limit equal to so many things. Instead of AB, I have used the symbols beta naught, beta 1, beta 2, like that. So, you will be telling me about the null hypothesis in terms of beta naught, beta 1, all those things. At least one predictor influences. That is the point. Can you tell me, that is, the question is, if at least one of the predictor is useful, my H naught, so if at least one of the predictor is useful, I will place it in the alternative. So the null would be the complement of that.
All predictors? All predictors are useful.
No, you said something else.
No predictor is useful.
What about that? All participants in this class are good. What is the complementary of that?
None.
All participants in this class are very good. What is the
All
complement?
participants
All participants are bad. Not all. Some participants are bad. Okay, so that means at least one participant, some or at least one. So at least one predictor is important. That the complement of that is no one is important. Beta 1 equal to beta 2, how far it was? Beta 10. All equal to 0. This is my null hypothesis. See, if my null hypothesis gets accepted, what remains of the model? Limit equal to what? Simply beta naught, constant. Only beta naught, all goes. That means none of the predictors are important. And then this alternative is if H naught. If this null hypothesis gets rejected, then I'll come to H1. H1 would mean what? If I write in language, at least one predictor is useful. That is my question 3. That is, I want to know whether out of all these predictors, at least one is important or not. That should be tested with the null hypothesis would be no, no one is important. If I cannot accept H naught, then I will say, okay, in my model, at least one. At least one means more than one also. One or more, they are useful. So the first question would help you to handle the joint impact of all the predictors. joint impact of all the predictors in assessing limit. I come to question 4 before I go back to R. I'll not come to question 5. Look at question 4. How is it different from question 1? Same question, more or less same question. Then how it is different?
Income.
Question 1 was also on income. If you remember question 1. Question 1 was on income. Question 2 was on gender. Question 3 is on all predictors. Question 4 again I am coming back to income. So why should I again do income? After eliminating the effect, then what happened in question 1? Question 1 is? Question 1 I wrote limit equal to, see I am writing it now, beta naught plus beta 1 income plus epsilon n. So what happened in question 1? Anything?
After eliminating income, the rest consider?
After eliminating income, no. See in question 1, what happened is this. And what is the difference? This was question 1. And question 4, more or less similar looking, but there is certain difference in this too. See, in question 1, what happened? I have not considered any data at all. I have just picked out the data on limit and income and I have done a regression. What are the other variables? I didn't bother to take those variables also. So only 2 variables. This was my y and this was my x. Only these 2 were considered in question number 1. Question number 4 is not that. Question number 4 considers my entire big model. All. Whatever I have written up to beta 10. So question 4 considers the bigger model. That means all were there. But even if I have considered all, then if I hold the other predictors fixed or if I can eliminate their impact, then what is the impact of income on limit? Question 1 never considered the other variables into its model. Question 1 behaved as if there are only 2 variables. Limit here, income over here. This question 4 considers all, then eliminates the effect, then tries to find out the residual impact of income on limit. That is question 4. So we answer question 3 and 4 first. So, you see that question 3 to 5 I've written and answer first 3 and 4. Here also, same function. So see, there is so much nothing and all those least square theory, all these things are done by the R software. Name of the function is ln again. Response variable is limit. Tilde. I have put a dot. Dot would mean I have considered all the variables. If you want to write down, then you have to type the name of all the variables as given in the credit data set. And if you do not type the names, if you just put dot, it would automatically mean that you have considered all the variables. But the problem is with this data. See, look into this data. What is the data? The data is the credit data. The credit data was having a number of rows and number of columns. This first symbol stands for the rows. I have chosen the information of all 400 customers. So I have not omitted any row. So if I have not dropped any row, I put a comma. Then why this -1? If you can recall your credit card data, just have a look once again. If you view credit, column 1 was ID numbers. I don't need the ID. ID, if I keep them in my regression model, it would act as a predictor. So IDs are not predictors. They are the roll numbers or the name that I don't need. So I have dropped this ID column. My predictor column starts from here, or my variable starts from second column. So since I have to drop this, I have just written it, that is I have chosen all over here. Okay, so I have chosen all the customers, but I have dropped the ID. -1 means drop column number 1. That's it. So this is my data, and I will run this data. This is done. There would be a summary function. Summary function would give you all the answers. Let us have a look. Intercept. You have that model. Beta naught hat -135.89819. You have income. This is the slope estimate of income. Then rating, cards, age, education, female, student, married. Then there is Asian, Caucasian, 2 things, I'll come to it. Then there is a balance. Okay, these were all the variables. Estimate is in column 1, standard error is in column 2. I will show you estimate, standard error, t-value are over here. And finally, these are the p-values. Star and double stars and triple stars indicate how significant they are. If there are no stars, you would understand that they are not significant. Okay. So if you come now into this last column, that is the p-value column, what would be your conclusion now? Come one by one. Okay. So another thing, so besides all these, look, if you have one single star, it would mean that yes, it is significant. Triple star would also mean, but triple star means highly significant. That's it. My question 3 was, if at least one predictor. To answer if at least one predictor, I cannot look into these individual things. I have to see something else. That is F statistic. This one, F statistic. You can see over here what it is written, 8941 on 11 and 388 DF. Forget about all these things. No need to bother. Just if you want to test whether at least one predictor is significant or not, then I have to do some testing problem which is given by the F statistic. We will understand it just by looking into the p-value. Let us see how much is the p-value. You can see that the p-value is small. Okay, you can see the p-value. -16.0000. So p-value is very, very small over here. So a very small p-value means H0 is rejected, highly rejected. If H0 is highly rejected, what would be your conclusion? At least one predictor is useful in predicting limit. At least one. So question number 3 is answered, because to answer question number 3, we should not look into the individual values, but we should look into the value of the F statistic and whether it is significant or not. Okay, so that value is very low, which would indicate that yes, H0 is rejected. Question 3 is answered. That means at least one predictor is useful. Now to answer question 4. Question 4 was saying that is income significant after eliminating the impact of all? Where should I look now? To answer about income, I have to look into this one, where I can get them individually. So what would be your conclusion about income? You can have a look into these 2 columns. How many stars are there, or what is the p-value corresponding to income? This is the p-value, isn't it? To the power -7, that means 0.0000. Exactly. So that means it is very low. Very low. So H0 is rich. Education is also not playing any important role in predicting the credit card limit when I eliminate the impact of the others. Female gender, we have already observed that it was having no impact. Student, can you tell me, look into this student, what is happening to student? Significant or not? Significant. Okay. Strongly significant. But just by saying strongly significant will not help now. I want something more. I want some more information now. Which information is available in this line? By saying strongly significant, I mean that means credit card limit is given more to a student or lesser to a student. A student is getting more credit card limit or less credit card. I know less. More. Some said more also.
Less. It is in minus.
Student is minus actually.
Give up.
T value is minus, that's why it's less.
So, this T value, student, yes. This actually means this is student minus non-student. Okay? So, whenever you are getting something over here, student, yes. This means it is testing student minus non-student equal to 0. That is the testing. So, student minus non-student equal to 0. So, that is not accepted. So, what is happening? Student minus non-student, that is coming out to be negative. Look into it carefully. Student minus non-student is coming out as negative. That means credit card limit given to student I think I'll be audible here also. Look into the student first. Can you please manage this? Answer was negative, minus 5 point. T value was that, the estimate was also negative. That is why this has come out to be negative. Credit card limit approved to a student minus credit card limit approved to a non-student. That has turned out to be negative. That is, which one is bigger over here?
Non-student.
Non-student is bigger. Okay. So credit card limit given to non-student is more than that given to a student. So you said correctly that the students are given less credit card limit compared to non-student. Right? Marriage, can you go through this marriage? Marriage, is it significant at all?
No.
No. So your marital status do not depend upon. That is, the credit card limit do not depend upon whether you are married or not. It do not depend upon that, but still, it do not depend. But this minus sign, can you tell me what about this minus sign? It is not significant. Statistically, it is not significant, but marriage limit given to marriage. minus the credit card limit given to non-married is negative. That means who are given more?
Non-married.
Non-marrieds are given.
Non-married are given more credit card limits. Those, I don't know why, but that is true. That is, but it is not statistically significant at least. Okay, there is no statistical significance, but this is strange. That is, those who are married, they are not given much credit card limit compared to those who are non-married. Okay.
Can we explain cards? Cards.
Cards,
Cards.
cards is minus. Cards, there is no problem with cards still, right? The cards has got no problem because it is not in categories, but still, card is what then come to the cards. Cards was 1, 2, 3, 4 like that. Okay, so it was numeric. The coefficient of cards has come out to be, the coefficient is not minus 13, but the coefficient is something negative. Okay, so if you see, it is like this, limit equal to, if I have the entire model is over there, I am looking into just the impact of cards. So there would be say some beta naught minus certain quantity say A into cards. Please interpret this. Significant আছে?
না না significant
That's very important. Cards are key. What is happening to cards? If your number of cards increases, that is if you possess a lot of cards, then credit card limit issued to you is less, minus. As your number of credit card goes on increasing, this also I didn't know. He pointed out, I never noticed this thing. If you have got a lot of credit cards, then your credit card limit given by the bank is going down. I didn't notice that. Any other thing? Cards you mentioned. So that is interesting. So possessing too many cards is not issuing you a lot of credit card limit.
Balance.
Balance is important. Balance I always check. Balance is something, it is how I am repaying my credit card loans. How quickly I am doing it. That is balance.
Ma'am, last
Last,
year.
last.
Balance से की होती है 5.8
Positive.
positive sign action. So what does it indicate? With balance is that indicate credit card limit significant. Yes.
significant
Significant watch. Coefficient, let me have a look into the discussion. The more balance you have, you are given more credit card limit. You have to check about this balance. Balance is about 0.42. The coefficient is 0.42. But it is positive. If it is positive, then for 1 unit increment in balance, your credit card limit increases by this amount. There are ethnicity, Asian, Caucasian. This means what? You see, I'll show you this. These are the key values. These are looking very high. Married was minus 28. Have a look just at this. What about this Asian? And you see that there were 3 ethnicities. One was Asian, another one was Caucasian, another one was African American. African American is not featuring over here in the table. That means African American has been chosen as a baseline. Okay, so this 16.80336 would be limit given to Asian minus limit given to African American. And that is positive. That means what? Asian are given more credit card limit compared to African American. Ethnicity is Caucasian. This means what? Caucasian minus African American. So when compared to African American, Caucasian are getting less credit card limit. In this way, you have to interpret whether, no, they are not significant. So if they are not significant, you need not interpret, but the signs are also very important. So this was about your, let me come back to this once again. Question 3, you look into that F statistic and the p-value corresponding to that F statistic. Question 4 means that is individually, by its side, whatever star and double stars, triple stars are. Question 5 says, how good is your model for prediction? Now we are doing this and that. I have chosen a model, a very simple linear regression model, multiple linear. I have chosen it to be linear. Is my model good? Whether I am doing a justice by saying all these things, I have chosen something. But whether it is good or not, that is one question. And then I have question, that was question 5. Question 6 is, I want to know the predicted values of all the response and find the residuals. And what is the mean square error? It will not be due to regression, just mean square error. And then I want to predict this. I'll come back one by one. Come to this. See whether my model is a good one or not. I say that was my question 5. The model that I have chosen, how do you justify that your model is a good one or bad one? That you have to take some value from this output table. That value is multiple R squared value. So to know whether your model is good or bad, you have to look into this R squared value. R squared value is a quantity that would lie between 0 and 1. 1 would mean a very perfect fit. 0 or near to 0 would mean a very poor modeling has been done. So you see that your R squared value shows that your modeling has been very good because it is very closer to 1. So you can rely on this model. So before using any model for prediction purpose, you look into this R squared value. If you find that it is very low, maybe 0.06, 0.12, then you do not use that model and make your comments based on that. Your model that you are proposing has to be a good model. Okay? So this 0.9961 gives you an answer to question 5, that yes, the model is good for prediction purpose. Question 6 says that we have to obtain the predicted values of the response. What does it actually mean? Question 6 says that, okay, you have fitted that huge model. By least square theory, you have obtained beta naught hat, beta 1 hat, all these things. The answers are provided in your software. You have performed the test. You know whether these are significant or not. Good. But can you tell me that what model you have done after doing this fitting? What is your predicted limit? That means, given all the information of those 400 customers as it is, now if you use your model, what is the answer of limit you would get? This is the question. See the question carefully. I would use all the information of those 400 customers. Information on cars, medical status, everything. And I will put those information into my fitted model. Then I will get an answer of limit. Will that answer of limit exactly match with this limit answer that is provided in the credit data set? Will it match? Yes or no?
No.
No. Why it will not match?
There will be some errors.
because of that error epsilon. But if it goes away a log, that means we haven't done a very good thing. So what we want now is to find out the predicted values of the response first. So I have done this y hat. That means y hat is the estimated limit. Based on what? Based on this credit data. Okay? But not this credit data. It will only have the credit data with data, comma, underscore. I don't need the IDs. I will predict this. So look into the function first, which is credit. I am using a simple function credit. I will predict which one? I will predict my model, which I have given by the name entry. What is data? Data is the credit card data on all customers, not the ID, and type equal to response. I want the response answer. I have just written as dot vector, that means it would give me an array of answers, only the y hat values. So if I do y hat regression, if I run this one, I would get an array of answers. And how will these array of answers look like? The array of answers would be like this. So this y hat, these are the answers. Say 5506. This is the 5506.3175 is the estimated credit card limit of the 400 customer. But all that customers, all other predictor information were taken as it is. This will not match with that exact answer. So what we get over here, these are my y hat values. So somehow I have used a model. So I will come to this. I have used a model to get these estimates. So that was my big, huge model. That huge model was used. All the answers were known to me. So I have got limit hat of all the 400 customers. Say I equal to 1 to 400. And as you mentioned, this will not match with the exact limit. Exact limit cannot follow something straight line behavior. So this is what I have obtained for the 400 customers. This is already in my data set. If I take this difference, this is known as residuals. That is, it will give me an estimate of that error. You can also write it limit I minus limit hat I, no problem, residuals positive or negative. This residuals will give you an estimate of the error that I have chosen as epsilon. Now, what we expect, epsilon to be very large or small? Because we have used a nice technique, a tool called least square theory. We want epsilon to be small, we want these residuals to be small, but naturally some residual will be 0, some will be greater than 0, some will be lesser than 0. Then if I do this residual square, if I square all these things, they will all be positive, but maybe very small number. So I do not want negative, positive to cancel out, because even if it is negative, it is something wrong. Even if it is positive, it is something error. So what I want is the square term. It is something positive. And if you take, so we will be having so many square terms for all the 400 customers. If you take the average, simple mean of all these things, I'm just using a symbol summation to indicate that I am adding up all these residuals and I am simply dividing it by 400. What we get is called mean square error. Okay. So, mean square error will have certain other degrees of freedom, but at least we can get or call this the variance of the residuals. Residual square like this, that. So we want that this value should not be too large. This is another goodness of fixed criteria, but this do not have any upper bound, unlike your R square. So, to check whether your model is good or not, it is always better if you see with that R square value instead of this. So, here we have also calculated the mean of this thing. We have got the residuals. We have taken the mean of the residuals. And you will find that this comes out to be a large figure, but its upper limit is infinite because it is something greater than 0. There is no upper bound. So to compare whether your model is good or bad, it is always better to check by that R square, because there you know that the upper limit is 1. Next, my question was this. This was an important question. Who can give this answer? Question 7. Have you taken down the coefficients? You have to do a little bit of calculation. Here I want to know what would be the credit card limit for a married female, non-student, Asian, having 2 credit cards, visa age 52, rating is 980, balance is 520, education is 16 years, income is 40. That means what? I have mentioned everything. So where should I go to know this, the credit card limit? Where to go? I have to go somewhere again over here. So I'll run it here. I will need another library. I will take it. Have a look. So the limit estimate, how will you give me this estimate? You will write minus 135 point this plus 0.342339 into whatever was the income I mentioned, $45. It is in 1,000. 45 into $1,000. So that is the income. So in this way, you have to fill it up. Rating, that means plus 30.213 into whatever rating I have mentioned. What is the rating? Is 980. Are you getting it? How to plan that equation or to form? This is important. That is, I want you to predict the limit of the person whose information are like this. So how do you predict the limit, the credit card limit of a person whose information are like this? You have to go back to this equation. If you have to just keep a track of whatever I have mentioned over here. Okay. Then your equation would be minus 135 plus 0.342 into 45 plus 13.21 into rating I mentioned something 850 minus 73.7 into number of cards was 2. So in that way you put in all these things plus 0.125 into the 52. Education is plus 0.39 into 60. Then plus 4.2 into female. Nothing very confusing, but the name is confusion matrix. Why? Because it is saying that as if I have become confused in classifying a person who is a defaulter to a person who is not a defaulter like this. Have a look. Here it is. Default. No? Yes. This is the truth. This side is the truth. Truth means what is actually, what the person is actually. That is over here. This side is my fitted no yes. Confusion means my fitted model has confused and mixed up and classified some defaulters as non-defaulters and some non-defaulters as defaulters. My model cannot be exactly perfect. So you have to allow something to that model that it cannot fit it exactly. But it is liable to make some error. That is what is meant by confusion. So the model has confused. In classifying some true defaulter, wrongly it has classified as not a defaulter, and some not defaulter has classified as defaulter. And this is what has happened. So can you tell me how many, and there has been 10,000 customers. If you add up all the cell frequencies, it would add up to 10,000. Can you tell me how many customers my fitted model has classified? How many customers correctly? Which figures I will take? Correctly. Has classified how many customers correctly? My fitted model.
105. 105.
How you are getting? Can you tell me?
Yes, sir, yes.
Which one you are doing?
Last one, 105, yes, sir, yes. No one color.
105. Okay. It has classified it correctly. 105.
Because the column and the row conjunction, both are yes.
Both are yes. So both are yes means what? Person is a defaulter. My model has classified him as a defaulter. My model is a good one. He has classified 105 persons who are defaulter, has classified them as defaulter. I'll look only into this 105.
No.
92.
This is also a good thing. My model has classified 9627 who are non-defaulters. My model has classified them as well as non-defaulters. So the diagonals over here are correct classifications. So this is your confusion matrix is like this. It will look like this. Diagonals are giving you correct classifications, but it has not been able to classify all the 10,000 customers correctly. Naturally, no model can fit the real life data perfectly. So it has not done. What are the errors? Where are the errors? In the off diagonals. Can you tell me then what is this error rate or something on error?
20.
I had that question, that is what is the chance, or tell me this specific question, what is the chance that my model would incorrectly classify, listen carefully, would incorrectly classify a person as defaulter
False negative.
when he is not a defaulter? Where should I look into?
False negative and false positive.
Yes. No, I just want one answer.
Yes. 228.
What I wanted? My model is classified.
228 plus one.
Our plus, I mean,
228.
what is this 228 then?
10,000.
228 is what? What I wanted, probability. Just see that my model has classified them as what I mentioned, defaulter. Defaulter, when truly they are not defaulter. So my model has said them as defaulter, I am writing as 1. But the true thing is that they are not defaulter. So if they are not defaulter and you are finding out my model is saying that they are defaulter, where should I look into? Please be careful. Not a defaulter.
Not B. Yes. D. 40. Yes. 40.
40. 40 is that number,
Divided by
but
2.
I have to divide it by something specific.
Total number of.
No, 220.
Total number of.
40 divided by
228
plus 40.
40 divided by 260.
Are no options. 10,000, so there is one option. Once again, just once again, this you have done it correctly. I have said, person is truly not a defaulter. Person is truly not a defaulter.
40 plus 9627.
Last one. The first column. Sum of the first column. 9627.
Ah, 49,627 is no.
Last 40.
Last one.
Last one.
Look into this. Nothing very difficult. Look into, it is a conditional probability. Look into first all the persons who are not a defaulter. Tell me the number of persons who are truly not a defaulter. Add column number 1. So total number of persons who are not a defaulter, that is 9627 plus 40. That is no. Out of these many persons, whatever is this figure coming out of so many persons, 40 has been classified by the model wrongly as being defaulter. Done? So this is first, given y equal to 0 means first you look into your data, find out all the persons who are truly not defaulter. Truly not defaulter is 9627 plus 40. Put it in the denominator. Out of this totality, my model has incorrectly classified 40 as a defaulter. So this is one type of error. And you know this error has got many names depending upon the context. Here we call it a type of misclassification. When it was COVID testing, it was given a separate name. This name is called, when we were doing COVID problem, we were doing tests. Truly we are not having COVID, but the diagnostic test is saying that I am having COVID. False positives. This is the case of false positive that happened, and false negatives also happened. And naturally, the other probability that I want now is that my model has missed some defaulter, said that that person is not a defaulter, when truly the person is a defaulter. The truth is that the person is a defaulter, but I have missed that person and I have called that that person is not a defaulter. What would be this answer?
228.
How much I should put in the denominator? That is better to answer first.
333. 333.
228
You tell me the figure. 228 plus
105.
Right. Out of so many people, my model has classified.
Numerator.
228.
Falsely negative. So that was in the medical case, but here we call it another error. So these two are the error rates. If you want to find out the total error rate, you can add it up. Okay. For any practical purpose, the model will not give you such a bad fit that these two probabilities being added up will explode one. Then your model is not at all a good model. Okay, so these things, or you can even report separately. Reporting separately is important. Now can you tell me one logical question from the view of a bank who is issuing the credit card? Which error is more crucial? This one or this one? So now look in terms of the bank, not from your side. Look from the side of the bank who will be issuing you a credit card, giving you certain limit in the credit card. The bank should be worried about which probability more.
Second. Marked as not defaulter.
This one or this one?
Truly defaulter but detected as not defaulter.
Truly default.
Truly defaulter but marked as not defaulter.
It depends upon the context. From the context of the bank, this probability is more crucial. Truly a defaulter But the mechanism that the bank has used has classified the person as not a defaulter. This is of more concern. The bank will focus on this probability more. It depends upon the context where one wants to classify or where one wants to look into. Okay, so this is about your confusion matrix and why logistic regression. And you see that this is just the takeoff point to advanced models. As he was mentioning, if I want to know which predictors are important, I just want to run the regression with only those many predictors. There are techniques, subset selection and all that. And so we have just in mind that if my response variable becomes binary, I cannot go for multiple regression, but I have to take course to something called logistic regression. And this is your confusion matrix, and you know how to interpret the errors. That's all, I think. And if you have any questions from here, I even have a problem set which you can use.
Participant, you have any queries? No queries? Okay, one information I want to pass, that is today there will be no test. Tomorrow we have your test, lab test as well as the overall test. So today we have I think 20 minutes. So you can discuss, you can ask queries also. And after that we have a photo session. And then tomorrow we will have our lab session test as well as the overall test. Anyone having any queries? Any queries? No queries?
So they were asking all the time. They have participated. Actually, my laptop charge is almost down. Should be an assignment or something.